Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Well, Houston, we don't have a problem. Today we're going to learn about how to add vectors. We learned about what a vector was in our last segment, but let's talk about what's adding and subtracting vectors. Well, why do we do this? Adding vectors is an important skill in physics, since vectors have direction and magnitude that cannot be added together like numbers, because you got that direction thing going on. They need to be drawn and added up tail to tail to determine their sum. There's also ways to do the resulting vectors, which we will learn a little bit later. So we need to figure out what this might look like. So step one, the first thing you do is draw the first vector. That's simple. The trick on the second vector, though, what do we do there? You start, I'll say it this way, at the end of the first vector. I'll show you what that means. It might be a little confusing. And the resultant, this is the fancy word, the resultant, that's the addition of the two vectors, is from the beginning of the first to the end of the second vector. Okay. Now I think it's best if we figure this out. So we have a new word here. Let's kind of dive in there. The definition of this word resultant vector is this. The sum of adding vectors together. Notice that's plural, so it could be three vectors. That does happen sometimes. All right, so let's do a couple examples. So let's say I have a vector here, right? And I'm going to add another vector, and I have this vector. So I've got these two vectors. I'm going to take the blue plus the green. So if we take the blue as the first one, it would be the same thing. And then the second one, I would just draw to the tail. It has to be exactly the same. I don't think I drew them exactly the same, but I think you get the idea. The resultant vector would be this vector here. Does that make sense? So this, the red, is the resulting vector. All right, so let's say that I have vector 1 here. Now I'm going to do one in the negative direction. Okay, you can have a negative, any direction counts. And I'm going to add this one off and to the upper right. So if I were to draw this again, right, again, if you wanted to get a ruler to be super accurate, we won't. I'd do the black, but then I'm going to take the green right here. And the resulting vector we'll make red is going to be from the beginning of the first to the end of the second. All right. And you can get even more complex, I think you're getting the idea, is I could have three vectors. So let's say I've got this vector. I've got a green vector that goes this way. And then I've got a black vector that goes that way. So we're going to take blue plus green plus black, right? So blue plus green plus black, and red will be our answer, of course, and that is the resulting vector. And you can do all the angles and with protractors and this kind of thing. Now we should talk briefly about what that might look like if you subtract a vector. When you subtract a vector, that's like adding the negative vector, which is the vector with the arrow in the opposite direction. So let's take a look at our example 1 here, and let's, instead of adding the vectors, let's subtract the vectors. So I will take blue, I'll draw blue the way it was, this one, and then minus green, then it's going to come back this way, and the resultant vector, I'll keep red as our standard, would look like that. So that's how you would subtract vectors. You're going to see why this is important in physics crazy soon, okay? Now some vectors are super easy. Sometimes you might have a vector that looks like, let's say we have a vector that's this way, and we're adding it to another vector that's in the same direction, right? Like this. And so you would just have, I shouldn't start with red, I usually the answer, but you would just be like this, right? That's the addition, and the resultant vector, in this case, I'll make it be black. So they can go in the same direction. And of course, you can also subtract them, and they would just, the resultant may be back in the opposite direction. Now, a perpendicular one, these are interesting ones. This is going to be much more common, if I have a vector here, and then I have a vector here, these are ones where we're going to have a 90-degree angle. And this is going to be a very common kind of a vector we're going to see. Because, like, for example, if I kick a ball starting down here, and I know this angle, we'll be able to predict in a little bit how far that ball goes. But these vectors, the blue and the green, are going to really matter when we do this. And the most difficult ones are the non-perpendicular. And we've done some examples of that. From a sort of a trigonometric, algebraic perspective, if I have this one, and then I go, like that, then I end up with one from a mathematical vector. Oops, I wanted that to be red. This one is going to be a more difficult one to deal with, and we'll have to do a little bit of fancy trig to figure this out. Not terribly difficult. Let's add one more thing and bring in some trigonometry. I'm just going to get a blank page down here that I think I need to do. So kind of the most common thing when we do in vectors is we talk about like a velocity vector. So let's say that I have somebody who's kicking a ball at an angle, okay? And so there's a person here who's kicking a ball. That's a foot. Okay, I don't know if that makes any sense. What we really want to do is we want to find out, and we know that the velocity of this ball, the initial velocity, is 10 meters per second. But actually what we do is we break it down into its components vectors. Oh, and we know that this angle, let's say theta, is equal to 30 degrees. Right? But what we really want to do is we want to break it down into the vectors that added to it, right? And if you think about it, this is, we call this V initial in the y direction, up, right? And this is V initial in the y direction, or x direction, pardon me. And of course we know the angle. Now you might remember back to old trigonometry, this funny thing called SOHCAHTOA. Sine equals opposite over hypotenuse, cosine of base over hypotenuse, tangent opposite over adjacent. And what I want to do is I want to find what VIY is in VYX. So this is a right triangle right here, right? And I know the angle. So actually what we probably would do it this way. We'd do it like this, and I would use this angle, and this is VIX, and this is VIY. Notice I can do it both directions. And so if that's 30 degrees, then VIX equals, so that's adjacent over hypotenuse, so it's cosine. So I can say cos of 30 is equal to VIX over 10, right? Because this number here is 10. And then what I can do is I can solve for the cosine of 30, multiply it by 10, and I can get VIX. In fact, let me go grab my calculator. On my calculator, I'll take cosine of 30 times 10. Oops, I gotta say cosine of 30 enter times 10. I got a weird answer. And I get VIX to be 8.6 meters per second. That makes sense if you think about it, right? Because it's going to be less than 10. And to get VIY, you would be sine of 30 is equal to VIY over 10. So I would do 10 sine of 30 times 10. Oops, sine, I can't do it. Sine of 30 enter times 10. And I get 5 meters per second. So it's going up at a speed of 5 meters per second, and it's going across at 10 meters per second. The resultant is 10. It's going across at 8.6, and it's going up at initial of 5. And you'll see how this will play a big role when we do these problems in class. And speaking of class, we'll see you in class.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.